Welcome students. In this video, we will be discussing about linked list. Okay. In the previous video, we were discussing about the idea of linked list actually, and why do we actually require a dynamic data structure. But in this video, we will be exactly seeing what is linked list, right? Fine. So in this video, there are five things. We are going to see five, topics like about. First of all, what is linked list? Second question is what is a node? Third one, node structure. Fourth one, how to create a node, and the last one is how to access a node. Right? Fine. The very first question is that what is the linked list? See here, I have just drawn a sample linked list here. This is similar to what we have seen in the previous video. In the previous video, what we did is we created a pointer in the stack. Then we created a node in the heap memory, and the base address of that node we are storing in the pointer which is created in the stack memory. Then we created one more node, second node, and the address of that node we were placing it in the first node. And we created one more node, and the address of that node we were placing it in the second node. The same procedure, it's the same format I have drawn here. This is a pointer which we have created here, and then this is the node which we are creating inside heap memory, and three nodes we are creating. Every node is having two parts. In one part we are storing the memory of the address of the next node. So in the first pointer, the base address of the first node is actually stored, and the address of the second node is stored in the first node, and the base address of the third node is stored in the second node. And there is something called as null here. We will see about null in this video, and this null is actually provided to tell the compiler that this is the ending node of the linked list. This is the ending node of the linked list. Okay, fine. The first question is, what is linked list? What is linked list? From the diagram, let me tell you that linked list is a collection of nodes. First node, second node, third node. So a linked list is a collection of nodes, whereas each node will contain a data part. Here you will be able to see each node will contain a data and as well as a pointer to the next node. What is pointer? Pointer is an address variable which is capable of storing address. So this is a part which is actually storing the address of the next node actually. So that is the reason why we are calling it as pointer to the next node, because pointer only we will be able to store the address. So this is a part where we are storing the address. So this can be called as pointer to the next node. So a linked list is a collection of nodes where each node contains a data part and as well as a part called as pointer to next node. Okay, fine. Now from the answer of linked list, we have some terminology called as node. What is node? That's the next question that we have. What is a node? A node contains two parts. It contains two parts. So a node contains two parts. One part is a data part. That is this first block, data part, and that data part can be of any type, either integer or float or character or double, any data type it might be. What is the second block? The second block is actually a pointer to next node. The pointer to next node. Okay, so Coming to the pointer to next node, what is the type of it? The type of first part is any type, because it is a data part, so any kind of data you can have. So integer, float, character, or double. Coming to your pointer to next node, because you have integer pointer, you have float pointer, you have character pointer, you have null pointer. There are many type of pointers available, and which type of pointer you have to take. So what is the type of this pointer to next node is the next question. Okay, this particular pointer to next node will be having the same type. Okay, same type of a node. First of all, we have to find what is going to be the type of the node, and whatever is the type of the node will be the type of this pointer to the next node also. Reason why? Because when I store the address of an integer variable, then we can store it in an integer pointer. The address of an integer variable in integer pointer. The address of float variable in a float pointer. Address of a character variable in a character pointer. So address of a node should be stored in the data type of the node itself. So first of all, you have to decide what is the type of node. Then only you can decide what is going to be the type of this pointer to next node. So whatever is the type of the node is going to be the same type only the pointer to next node also will be taking. Okay, we will try to find in the next question what is the next one is node structure, and through this node structure we will understand what is going to be the type of a node. What is a type is actually, what is a node actually, right? So how to define a node, in C program. Okay, that we will see now. Okay, so we are going to see a structure. Because when do we require a structure in C actually? Okay, we require structure in C. Structure is a derived data type. When will we require structure? We require structure to actually store the related data member. We actually require structure to store the related data members. So there is a question, what is a node? What is a node? A node is a combination of data and as well as pointer to next node. So you have two data member, you have two member. Okay, one member is data, the other member is pointer to next node. Okay, so these two are a related member because both data as well as pointer to next node, these are two member related to single node. Okay, so these two variables or these two members can be written inside a structure because both belongs to both are related to a single node. So what is a structure? A structure is a combination of related members, related data member, or otherwise it can be a pointer also. So here we have one data member and one pointer member. Both these members are related to a single node, so we can probably write a structure. So how to write a structure? A keyword called a struct, followed by, you can give a name to the struct that you are going to define actually, then followed by curly braces, and this curly braces points that you are opening a block, and inside this you have to define what are all the members. First member is a data member. What type of data? Now we can, any type of data it can be, but now let us just define that it is a integer data. So int data, so it is a integer data. Okay, fine. What is going to be the second member? The second member is going to be pointer to next node. Okay, pointer to next node. Now tell me, what is the type of the node? Type of the node is struct node. What are all the data types that you know here so far? You know integer, float, character, that is char, or a double. So these are all the data types that we know so far. Now structure is a derived data type. This is also one of the data types. So we are defining a new data type, and the data type name is this along with the struct keyword and the name that we give. Both these things together can be considered as a new user defined data type. It can be considered as a new user defined data type. So now why I'm telling this is, I told you very clearly that what is the type of the pointer to next node. The type of the pointer to next node is same as the type of the entire node. So what is the type of node? Struct node is the data type. So now what is the pointer now? Pointer has to be struct node pointer. That's it. So the type of the node is struct node, and the pointer to the next node should be a struct node pointer, because this pointer that we are going to take now is going to store the address of a node. It is going to store the address of a node. So when I want to store the address of an integer variable, then the pointer is going to be integer pointer. If I want to store the address of a float variable, then it should be a float pointer. We are now storing the address of a node, so you have to store it in a with the same type of the node. What is the type of the node? Struct node. So if you want to store the address of a struct node, then the pointer you should use is struct node pointer. Very simple. So we are going to take a pointer, struct node pointer. So struct node star. Then you can have a name for it. Why this pointer? What is this pointer to next node? So this is for storing the address of the next node. So let us have the name next, for example. This is the node structure. This is the node structure. So far what are all the things that we have seen so far? What is linked list? Linked list is a collection of nodes where each node contains data and as well as pointer to next node. Okay, next one. What is a node? A node contains data part and pointer to next node. Whereas data, coming to data, it can be of any type. Coming to pointer, pointer should be of same type as the node. What is the type of the node? Type of the node is struct node. So the type of pointer also should be struct node pointer. So these are all the things that we have seen so far. We have discussed so far. Right. We have so far defined a node. We have not created a node. We have defined a node, how it should be. A node should always have a data part and a pointer to next node. This is what we have defined. Just we have defined the structure. Okay. Now we have defined the structure of a data type, how a data type should be. Okay. This is a new data type that we as a user are defining. So this is the structure for the new data type. Now the next question is how to create a node. That's the next question. How to create a node. Okay, fine. How to create a node? Creating a node, where we are creating it in the heap memory. When you are creating it in the heap memory, I told you very clearly that how to create a block in heap memory using dynamic memory allocation functions like malloc and calloc. Okay, so now let me just teach you using malloc statement how to create a node. Right? Fine. So first of all, what we will do is we have to be creating a pointer. We have to create a pointer to store the address. See, here we created a pointer in the stack memory to store the address of the node that is going to be created in the heap memory. So first of all, I want a pointer. Now tell me, what should be the type of the pointer here? What it is going to store? It is going to store the address of a node. So what this pointer type should be? The pointer type should be the type of the node actually, because it is going to store the address of a node. So what is the type of node that we already have seen here? Struct node. So what should be the type of pointer we should take now? We should be taking a struct node pointer. So struct node pointer, struct node star. And now you should have a name for the pointer. So the name for the pointer that we are going to take here is first, because this is the first node that we are going to create. Okay, equal to, either you can create a node in the next line also, and also you can do it in the same line. We will do it in the same line. Subsequently, I will also tell you how to do it in the separate line. So struct node star first is a pointer equal to. Now we need to use a malloc function to create a node in the heap. So malloc is the function, and in the argument of the malloc function, we should provide how many blocks we need to allocate. 5 block, and each and every block how much by how many byte it's going to take. Actually, we are going to take, see each see. So first of all, we should know, see, for telling how much byte we need to allocate, first of all we need to understand the size of a structure. Because if it is an integer value, then I will just simply write size of integer to find the size of the data type. Now you have a data type called a struct node. How to find the total number of byte that will be required, okay, or otherwise the total number of byte needs to be allocated for the data type struct node. How to find it? With the same size of operator, because I told you struct node hereafter is similar to integer, float, double character. It is also a particular data type. Struct node is hereafter a data type, but it's a user defined data type. So you can use size of operator, and size of what you can provide here, size of, I can provide the data type. So struct node, okay. So you have find the size of the structure, the data type struct node, and you are multiplying it with 5. So how many, sorry, okay, I think we are not creating 5 nodes, we are going to create only one node. So I think better you can just simply simply give size of struct node. So size of struct node, what will happen? Only one node will be created. Okay, fine. So for example, if the size of the node is 12 byte, then automatically size of operator will be finding, after examining the definition, this size of operator will find that determine the size of structure, that it is 12 byte, and it will give instruction to malloc function saying that 12 bytes need to be created in the heap. So continuous memory blocks. Okay, continuous memory block in the sense you want two block, right? You want 2 block for a structure. You want 2 block for a structure. So what will happen? 2 block, which is going to be adjacent to one another. Okay, 2 blocks adjacent to one another will be created because of this malloc statement. So this malloc function will be creating a node which consists of 2 block. You can see here you created a node in the heap which contains 2 block. Here you can able to see the member of the node. So 2 member of the node are there here. So this entire node will be having a base address. Now that's the next thing that we need to discuss. Okay, so malloc will automatically create a node there. Now the next thing that you need to understand is, okay, the next thing that you need to understand is what this malloc function will be returning. So it is created, and we need to get the address. How to get the address? Okay, so before getting the address of the node, there is one more thing that you should keep on mind is malloc will return a null pointer, using which you cannot do anything. Null pointer, which means nothing, void pointer. Okay, so using which you cannot process anything. So what should happen? Typecasting should happen. Typecasting is from one data type to another data type. We want to cast it. How can it be done? In front of, okay, in front of malloc, you should provide a parenthesis, and inside parenthesis you should mention the type to which I'm going to cast it. So it is a void pointer, but we need to typecast it into what pointer? Because what pointer we are having here? It's a struct node pointer. So you should typecast it into struct node pointer. For pointer you have to mention star. Okay, so you have allocated the required amount of memory with the help of size of operator, and you have created a block in the heap memory, node in the heap memory, and the address of that memory, that block, that node which is created in the heap, you will be receiving when you typecast it. So how you have to typecast? You have to typecast using the type of the pointer, same as the left side pointer. Now what will happen? The base address of the node will be now written, and that will be stored in the variable or pointer called as first. Okay, fine. So what has happened so far? We have seen what is linked list. We also have seen what is the node, and also we have seen a node structure. Okay, and from the node structure we clearly said that struct node is hereafter a user defined data type. Then we also have seen how to create a node. With the help of malloc function, we created a node and then typecasted into struct node, the current data type. We have we have typecasted it into struct node pointer, and the base address of the new node created is now stored in the pointer first. So with the help of the first pointer, now we will be able to access the data member of, access the member of the node. What are the member? One member is data, another member is pointer to next node, which is we are naming it as next. Okay, the next question is how to access the node. So you have created a node, how to access the member of the node now? That's the next question. Okay, so how to access it? I'll just tell you now. Right, so first of all you should specify the name of the pointer. So what is the name of the pointer? First. So first, in the sense, you can able to see here, first means here, this pointer is having the address of the first node that which you have already created here using this statement. You have created this node, and the address of that node is now stored in the pointer called as first. With the help of first, the address stored in the first pointer, you will be able to move to first node and access both the member of it. Okay, so how to do it actually? One minute, guys. So first mention the name of the pointer. Okay, this pointer called as first. Now from this pointer, how to move to this node is the next question. If you're already familiar with structure, then it is you very clear. Then if it is a normal structure, if it's a normal structure variable, then you can use dot operator to access it. But you can just simply say that first is not having any data member and next member. First pointer is not having. This node is only having. So there is no, it's not logically you cannot give first dot data or first dot next, because first is not having any data member and it is not having any next member. So first of all, what you need to do is from this pointer, you have to first of all move to node and then access data and next. How to move from first pointer to this node? You have a selection of member selection operator called as arrow mark. So hyphen greater than symbol. This arrow mark operator will move you from first to the block which is having the address 200. So whatever address it is holding, it will take you to that particular node with the same address. That is what the job of arrow mark operator. So this arrow mark operator will take you from this pointer to this node. After moving you to the node, then what you have to do? You have to mention either data, or otherwise you can mention either next to access either this first part or the second part. Either first member or otherwise second member. Either data member or otherwise pointer to next member. Right? So what is that you have to use? Actually, you have to use the member selection or member selection operator, which is arrow mark, that is as hyphen and a greater than symbol. This is only you have to do it only if you are in the pointer, if you're using a pointer variable. So I think you in the previous statement, to create a node, what you have done, you have taken a pointer. So if it is a pointer, definitely arrow mark have to be there, because pointer variable are not having the member called as data and next. This node is only having. How to move from this pointer to this node? Using arrow mark. So when you provide arrow mark, then the movement will happen from this particular pointer to the very first node. And then after moving, then you can either access the data part, otherwise you can access the next part. Okay, fine. So what we have done so far in this particular video, we actually started with what is actually linked list. A linked list is a collection of nodes where each node contains data and pointer to next node. Then what is a node? A node is something that consists of a data part and as well as pointer to next node. What is data? The type of data, it can be anything: integer, float, character, or double. Coming to pointer to next node, we decided that pointer to next node is storing the address of a node. So whatever is the type of node should be the type of the pointer also. Very clear. So the type of the pointer here was exactly struct node, because the type of the node was struct node. That's the main reason. Then we saw a structure, node structure. Then using with the help of, see, one thing that great mistake that I'm doing here is semicolon at the end of the structure, right? Fine. So after defining a structure, with the help of the structure, we created a node with the help of malloc statement. And this malloc function, where it is defined, it is defined inside a header file called as stdlib.h. Okay, then after creating a node, then we are seeing how to access a node. That's using the arrow mark operator, or otherwise member selection operator. Okay, fine. In the next video, we'll be seeing more about linked list, few frequently used syntaxes, and the purpose of using the syntax. Everything we will see a small demo of it. Okay, fine. Thank you.